Hi Asia, how you doing?
Hi, I'm doing good.
You've been over here a while ago, you know.
Me, I do good. I,
Okay. Oh, you reach home now?
yeah, not too long ago.
Okay, good, good, good. Ready for class?
Not even know when
It
it
a work
starts.
experience. It's a go start chat. Question, a work experience at the pan?
No,
Oh, other thing. Okay, okay,
yeah.
good. Alright, that's good. Alexia Montague.
Evening, Asia, Michael.
Evening, oh God.
Nothing much.
Hi Marshall, good day. How you doing? Good evening, everyone.
Yeah, teach today, Michael.
Evening, sir. Not going to be at class today?
Sir, I come on, but you may go and teach till him come.
Oh,
AJ, you not happy?
Just give me some of the pay.
No problem. All right, so we are starting the structure of the Earth. And Sir sent a document in the group that we were supposed to read before class. So we're going to basically go through the document until Sir arrives. So, all right, so the document basically is contrasting students and scientific view. So it's basically explaining firstly what students experience or understand about the structure of the Earth. So students' everyday experience. Understanding what lies beneath the surface of the Earth is particularly difficult for students because it is beyond their direct observational experience, which is what they see. While students have seen images of erupting volcanoes and be aware of earthquakes, the idea that rocks and continents are constantly moving as a part of an enormous but relatively thin tectonic plate is a very demanding one, as it creates a substantial mismatch with what we all are able to see. This mismatch becomes even more extreme with the issue of time, given that the time period involved.
Good afternoon, students. How are
Afternoon,
you?
sir.
All right. So thank you very much. I see the article on screen. I am actually in commute. I'm not hearing if you're speaking, but just listen to what I'm saying, please. I am in commute, and I'm gonna ask if you can just go through that document for me, please. In its entirety, we're looking at the structure of the Earth. I have some other stuff to share with you, but hopefully, I'm hoping that I get within another half an hour thereabout. So by which time you should be able to finish reading that document and then we can continue the session. Thanks for understanding. I'm going to be logged in, but I may not hear you. But should in case you have something you can try, I may be able to get it. All right.
Okay, sir. All right, so continuing, this mismatch becomes even more extreme with the issue of time, given that the time period involved in the movement of tectonic plates are huge and way beyond anything students have encountered before. This is a total contrast with the extreme short in geological time involved in the idea they will have of earthquakes and volcano. So this basically is saying in terms of geological time, you're able to see and experience a volcanic eruption. You're able to experience the shaking of the earth during an earthquake, and both are linked to geological activities. So to use that as a measuring stick against tectonic movement, you might say, boy, it's not possible because tectonic move too slow. The earth is as is, or it is right now. So that's basically what that is saying. Further in the document, the ideas are also related to the focus on geological time, as was stated earlier. Views held by students include that soils can extend several kilometers under the Earth's surface. Lava in volcanoes comes from the center of the Earth. It is pushed up to the surface. Landforms such as mountains, seas, and continents do not change. They have always been where they are now. Under the Earth, there are centers of fires, magnets, and underground seas. The crust floats on a sea of liquid rocks. That is, the Earth contains only molten rocks, except for the solid crust that we are on. And this research was done by Blake in 2005, Dahl 2006, and Phelps in 1991. Students often believe that earthquakes occur when the sun's hot heat. Students often believe that earthquakes occur when the sun heats the Earth's surface, causing it to expand and cracks, while others believe the earthquake erupts. Apart from believing that lava comes from the center of the Earth, other views about volcanoes includes volcanoes are not formed in cold climates, only in warm areas. They do not have snow on them. Volcanoes become active and erupt when they are too full of lava. And research was done by Dove 1998, Biz and Hops 1994. So when students are asked to draw a sketch of what lies beneath their feet, they frequently draw a diagram similar to the example shown below, which has dirt, bone, rocks, roots below the surface, with the possibility of a layer of that includes lavas. All right, so the scientific views is a little bit different from that of which students would typically have. It is about 6,400 kilometers from the Earth's surface to its center. For convenience, the distance below are expressed as percentage of this figure, as well as given directly. Evidence from earthquake, volcanoes, and igneous rocks, which sometimes contain fragments of what is thought to be upper mantle material, suggests that the Earth is made up of four principal layers: the crust, the mantle, outer core, inner core. So the crust, which is solid, can be as thin as 6 kilometers in some oceanic areas, and generally about 35 kilometers, which is about 5.5% thick in continental areas. Soil, where present, form a very thin layer, at the most a meter thick. The crust rarely exceed 50 kilometers in thickness. The mantle is made up of rocks. It's made of rock material that is more dense than the crust. Is around 2,900 kilometers. And that varies between 0.5 to 46% thick, and is predominantly solid all throughout, localized melting can occur because of the high pressure. It can show plastic flow in the same way that ice flow in glaciers. The consequences of this flow are tectonic plate movement and resulting in earthquakes and volcanoes. Everybody understand that?
Yep.
Yep.
All right. So we move on now to the outer core that extend from 2,900 to 5,150 kilometers below surface, and below the mantle, and that is roughly 46 to 81% below the surface. It is liquid and made predominantly of iron, a very much dense material than rock material in the mantle and the crust. A small amount of other elements. The Earth magnetic field is a result of convection current in the outer iron core. The dense inner core extends 5,150 to 6,370 kilometers, the remaining 19% space below the Earth's surface. It is solid and made up of almost pure iron. The molten rock that is part of volcanic eruption flow from the lower crust and upper parts of the mantle. It is usually originated from no more than 100 kilometers. That is 1.5% below the Earth's surface. And this material from the core never reaches the surface of the Earth. The crust and the top layer of the mantle, down to a depth of 100 kilometers or 1.5%, are called the lithosphere. The lithosphere is solid and rigid. A network of 14 major and a number of minor tectonic plates make up this layer. The solid plates carry both continents and oceans and move on the top part of the mantle. Heat and very high pressure means that the rocks in this top part of the mantle can flow slowly, but like ice glaciers, it would be incorrect to say they are liquid. You know, you guys know what a glacier is, right? Hello.
Yeah, the rivers of ice.
Repeat, what kind of ice?
I'm saying the rivers of ice.
No, not rivers of ice. It's basically like mountain blocks of ice. So you have like Alaska that has a lot of glaciers.
Like up at the North Pole.
North Pole, yeah. So those big blocks of ice, they tend to move. Like say they move like 1 centimeter a year. Yeah, so that's basically the same concept with the movements of the plates. So that's why they say it's incorrect to say that they're liquid or they move slowly, like the glaciers, and it would be incorrect to say that they're liquid. Glaciers are like solid blocks of ice.
Before you move on, I have a question.
Sure.
And scroll up a little, please. Back up to the last paragraph. You're right. So,
Last part.
so like,
Alright.
right now, you're right. It's right. So like we say, the lithosphere is the top part of the mantle
Mhm.
and the crust, and it said solid. So how it travels, wait, so which part it says? It says flows from the lower crust. It's a molten rock. So if it's solid, how is it molten rock?
Which one of the line? Let me
Click
look
on the
back.
last paragraph. So the molten rock from
This one?
volcanic eruption, yeah, come from the
Mhm.
lithosphere. And
Mhm.
then the paragraph below it, it's a lithosphere, solid and rigid. So
Mhm.
all the molten rock.
Remember
Oh.
subduction zone. Remember the subduction zones?
Mm-hmm.
Yeah, what happened at the subduction zone is that under pressure and heat, that's when the lithospheric rocks become liquefied.
Oh, so it's
And that's
molten.
how that's how it becomes molten.
Oh. All right. Thanks. Can continue.
All right. So hold on. All right. So we're gonna have all right, so critical teaching ideas. So plate tectonic is a very good example of a big scientific idea that is useful because it explains so many Earth-related phenomena. The Earth surface consists of a number of huge plates up to 100 kilometers thick, which move at a speed of about 2 to 15 centimeters a year. And that has a lot to do with convection currents. Volcanoes and earthquakes are largely the consequence of plate movement and often occurs at the edge of these plates. Which plate movement margin would you find earthquakes? Predominantly earthquakes. Anybody?
Oh, sorry, I could unmute. Oh wait, the convergent. When they come together.
No, transform. San
Oh,
Andreas
transform.
fault. Yeah. When they pass each other and them rub, the friction creates earthquake. Volcanoes will be formed at the convergent because you have the zone of subduction. And you do get your full mountains from that as well. So earth scientists have
Oh, but yeah. No one that's not mix it up because earthquakes are also form at convergent.
Adam, what did I say too?
yeah when
Earthquakes
you
and
have
volcanoes.
that you have earthquake because when you have the subduction zone, eventually the pressure would the snap pieces of the they call it now the continent that is being subducted, and you have a result. You have earthquake, and you have a lot of that at the but you have most of the earthquakes are transformed because the friction that occurs when the two plates pass beside each other.
All right.
So earth scientists have proposed that the earth is constructed. Hold on, let me read that over. Earth scientists have proposed that the earth is constructed of layers. This model is derived from evidence from earthquake waves, volcanoes, rock types, and the Earth's magnetic field. Oh, gone too far. All right. An understanding of the layered nature of the Earth is central to understanding plate tectonics and geoscience, earth science. Geological process such as the movement of continent, mountains formation, the worldwide distribution of earthquakes and volcanoes, an aspect of evolution, including the products of Australia, unique flora and fauna, and the distribution of fossils, all depends on understanding plate tectonics. The very slow movement of solid continent plates across the plastic lower layers. This topic also allows students to explore how scientists construct understanding and explanation of things that they cannot directly observe. How can they know? Can be an important theme for studying, for study with this context. Although the information at the following website is not appropriate for students at this level, it is included here as a teacher resource because it provides good explanation of the working of shock waves from earthquakes are used by earth scientists to reveal information about the size and properties of the principal earth layers. You can have a look at that at a later date. All right, can I have a reader, please?
All right, so I'll read.
Thank you.
All right, the teaching activities. Because students usually observe only small changes in the Earth's surface, the viewing of videos and animated websites showing dramatic land transformations alone are unlikely to change the students' existing views. Students should be introduced. You sure that part is necessary?
All right, which you want to go down to the
Almost
idea?
kind of sound as if like they, yeah.
All right. Let's see. All right, this more so like a discussion.
Yeah.
All right. So we're gonna just have a look at discussion then until sir is able to. All right, so we'll start with the first one. All right, so these questions just would come from what we have just read. So question, how deep is soil? Or is the soil? Anybody?
That's the crust, right? How deep is the crust? Basically with the earth.
No man, how deep is the soil? We just read it. No, the crust are different measurement. I'm gonna go back and see if I can spot it. You see? Asia, you're close to it, you know.
More meters thick at most.
At most 1 meter, correct. All right, so where are the rocks? Where are the first rocks? Anybody?
Not a clue. I remember reading this.
The mantle is made up of rock material that are more dense than the crust.
It never say where the rocks are from. But another to see.
Read it, finish read it.
The first rocks would be the igneous rocks, right? That are found in the upper mantle.
All right. Sarah go justify that one now when later.
Not even you don't know the answer.
I was thinking about the first rock being that was in the mantle.
Yeah, me that just leave it at that based
Yeah.
off of what it was saying. Me that just said a mantle.
Yeah, that's what I thought. All right. So where would you find lava? Before you answer that, you know the difference between lava and magma?
One is on the outer surface and one is inside the earth still.
All right. So where would you find lava?
Now we talk about a
Crust.
volcano.
Wouldn't the lava be in the crust of the earth
No,
or on the crust?
yes, you're right. The lava is actually when the magma actually reaches surface and flow.
Yes, so on the crust.
It would be in the crust.
On the crust. Okay.
And yeah. Oh, I actually give it that. Where does lava come from?
Now the lithosphere, the part of the mantle going through the
Sure.
crust.
You sure? Sure, Asia. Asia?
I'm not 100% sure that what I say.
Paz, you want to give that a try?
I'd say the lithosphere as well.
Lithosphere?
Because it said where it came from. So that's why I would say that it's the lithosphere.
But if the lithosphere is solid, rigid, how would they get lava there?
Based off of the convection current, as you say, where you have the heat and the high pressures.
Yes, causing it to be melted, as what I said before.
I go on good, man. Yeah, no correct, man. Just want to make sure so no answer madness. What is in the center? What's it like in the center? I know that's the center of the earth.
It is solid.
It is solid.
Mm-hmm.
And what is the center made up of?
Iron.
Yeah, iron.
Rare iron.
Mostly iron.
Mostly
Except
iron.
almost pure iron. That's what is on the document.
So you're not. It has nothing else than almost pure iron.
It wasn't mentioned on the document.
You sure?
Yes, I'm looking at it. The document says the dense inner core extends from 5,000 6,150 to 6,370 kilometers. The remaining 19% below the Earth's surface. It is solid and made of almost pure iron.
All right, that is. No, I never say it wrong, you know. But
No, I'm
there's
just saying
other
that I'm just
there
saying
are
that
other
that is what
elements.
the document says. They never mention anything else.
Okay, okay. All right, I'm gonna play a video. I'm gonna play a video. Hold on, let me bring it up. You're seeing my email right now?
Yeah.
Yeah.
All right, hold on. All right, I'm gonna refresh this. Uh, um, wow. All right, you see the video?
Little
Yeah.
load.
All right.
In this video, we're going to read about the structure of the Earth. Basically, this picture. This represents the interior of the Earth divided into different layers. So we're going to read about each one of them. The first layer is the crust. It is the outermost solid part of the Earth, basically this region over here. It is brittle in nature because during an earthquake, it is the crust that breaks easily, causing a fault. And we know that the density of material increases as we go more and more deep. Therefore, the materials which are available in the crust have low density. The thickness of the crust varies under the oceanic and continental areas. And this is obvious because ocean is like a cavity filled with water. If you remember Mariana Trench in the Pacific, it is the deepest known part of the world's oceans with a depth of 10,994 meters, almost 11 kilometers downwards. The mean thickness of oceanic crust is 5 km, whereas that of the continental is around 30 km. So if you drill on the ocean bed and you go 5 kilometers deep, probably you'll touch the next layer of the earth, which is the upper mantle. Similarly, if you drill on a continental crust, it will take around 30 kilometers to reach the upper mantle. Again, the thickness of the crust will be more near the areas of mountains, and you can figure out as to why. It is as much as 70 km thick in the Himalayan region. Again, we know that Himalaya was formed due to the collision of plates. When two continental plates collide, it folds the rocks at the boundary, lifting it up and leading to formation of mountains and ranges. Therefore, the thickness of the crust in these regions will be naturally higher. The second layer is the mantle. This region over here is called as the mantle. So right from the end of the crust till the outer core is a region that is 2,900 km thick. The upper portion of the mantle is called asthenosphere, but this region and the crust together is called lithosphere. Astheno means weak, and due to its weakness, the magma finds way to the surface during volcanic eruption. Now the total thickness of the crust and upper mantle, which is also known as the lithosphere, is 200 km. The lower mantle extends beyond the asthenosphere and it is in solid state. This layer is also responsible for all of Earth's volcanic and seismic activity because 2,900 km thickness is pretty spacious area for the formation of such natural catastrophes. Now, laboratory experiments on rocks and minerals say that between 100 and 200 kilometers below the Earth's surface, the temperature of the rock is near the melting point. Therefore, molten rock erupted by some volcanoes originates in this region of the mantle. Remember this, the core of the Earth consists of nickel and iron, but here in the mantle, it is the molten rock that is fluid and can move. It is this fluidity that powers the movement of the tectonic plates of the Earth's crust. The third and the final layer is the core. Core comprises of the inner as well as outer core. Now, moments back we have read the thickness of the mantle is 2900 km. So after that immediately the boundary of outer core will begin. The outer core is in liquid state while the inner core is in solid state. I've made a short video on this curious question. If at all you're interested in finding out the answer, head to the link in the description and find out. So the density of the material at the core is going to be the highest, and we have repeatedly read this, that the density of materials increases as we go more and more deep inside the Earth. The core is made up of very heavy material, mostly constituted by nickel and iron. It is sometimes referred to as the knife layer. So Ni and Fe are abbreviations of nickel and iron. Remember this term, knife layer. As we know that the Earth's core is divided into two layers, the outer and inner core. The outer core borders the Earth's mantle and is approximately 2300 kilometers in thickness. The inner core has a thickness of 1200 kilometers, giving the core a combined thickness of 3500 kilometers. The outer core consists of nickel and iron in molten state, with a temperature range between 4000 to 5000 degrees Celsius. The inner core, on the other hand, is composed mostly of iron and has a temperature range between 5000 to 7000 degrees Celsius. And the inner core is mostly solid. This was all about the structure of the Earth, which are divided into separate layers, and hopefully you have gained some meaningful context regarding it. If you want to see more of such educational content, make sure you're subscribed. By doing so, you'll get an alert when my next video comes. Thanks for
Okay, anybody wants to share, add anything to that?
Not me.
Alexia, what did you understand from the video or the document that Sarah sent? Marshall,
Hello?
evening. What did you understand from the document or the video? The document that Sarah sent or the video?
So sorry, Mikey. I might to get that you guys finish the document now.
Yes, sir, and watch the video.
All right, cool. All right. About I'm in Kingston. There's no traffic away from home. So if you're finished, you can take a little another 10 minutes. All right.
Okay, 10 minutes break. All right, guys, we're in recess for 10 minutes.
Okay.
Hey guys. Hold on. I need to disconnect the connector. All right. Um, so good afternoon again, students. How are you?
I'm good, sir.
Nice.
Afternoon, sir. I'm good.
Yeah, man. Now, let me just tell you something straight up. Unapologetic in what it is that I'm saying. Unapologetic. You guys are the true definition of what a science student. Are you hearing me?
Yes, sir. We're hearing
Yes,
you.
sir.
Yes,
Oh,
sir.
that's at my screen. Your meeting should start in a few seconds. Oh, my screen just went blank. You guys are true definition of what science students supposed to be. Responsible. Responsible. And trust me, I couldn't hear. I had the phone between my legs. I could only see that, screen was moving, and I was assuming that the document was being read. I don't understand what is that mean right here. The document was being read. I'm truly, proud of you guys, with your level of responsibility. All right. So the handout that I sent to you previously was a handout on the structure of the Earth, and I know you would have read. And so let me apologize. Had all plans of leaving before time, because I know I have a responsibility for 5 o'clock, but the institution is going through an impasse, and I got a call at about, I would say about 4 o'clock ish, and that I know if I started driving, I would lose a call, and I had to deal with it. At which point I say, you know what, and I don't think I can make it in time. So I sent out a document for you to read through in the meantime. So I was absent physically from class, but trust me, I was still engaged in the work of the institution while in absentia. But so thank you for reading. You did not lose any time because you guys went through the handout. I don't think I could have done that stellar of a job that you guys did. But anyway, this John from my browser. All right. Jesus. User camera. What are you saying? I don't want that. All right. You hold on a minute here, because okay, now I'm back. All right, so I want to just bring something into focus. I know you guys read through the document, but oh geez, so where I would have started today would have been a review of what it is that we did on Monday. Did anyone look back at what it is that we were talking about as it relates to the nebula hypothesis, the Earth as part of the solar system? Anybody?
No, I did not review that.
Okay, that's fine. So yesterday, I think I sent you guys something
about a live feed about the comet.
Yes, sir.
Anybody was able to at least watch a piece of it?
Yes, sir.
Maybe want something catastrophic happen. I was praying for something catastrophic to happen, and don't tell me that I'm unnice. I wanted to even see a supernova taking place somewhere. I just wanted to. I mean, I don't know if anybody saw the countdown to say that in a possible supernova in 30 minutes, and then it started counting down, and when it reached 0, it started another 30, because I guess people were also, saying that, hey, we can have a possible supernova taking place here, and of course everybody knows what a supernova is, right?
No, sir.
All right.
Okay.
It is where you will have the collision or explosion of stars, coming and crashing into each other, and a big explosion. And this occurs really with those stars that are dying, right? So it supports the theory that we're talking about earlier. You see, I like the connectivity with this thing. It supports the theory that we spoke about earlier, and I don't know if you guys remember it. We were saying that some of these galaxies and stars must die out to make room for new ones. Remember I had that conversation?
Yes, sir.
Because if that didn't happen, it means that the sort of stretching that we're seeing, we wouldn't see it, because I mean, all of those will be filled with these many stars and galaxies that are birthed, so to speak, right? But yes, the supernova will take place when you have these stars crashing into each other, exploding, and you'll see a big. Of course, if you have an explosion, you'll see, something catastrophic happening. You'll see evidence of it, and they're saying that some of them are saying that the supernova is visible with the naked eye. So me sit down there with one computer or watching something and I listen, and then of course doing excess work on another computer, because I'm there saying, let me see something. I want to see something in this real life. I want to see something, but maybe it would be too catastrophic if something really happened. But yeah, call me weird, but it's always very interesting when you see developments such as these. All right. If only I can find it. Let me see if I can see it. The downloads. I know I downloaded something for you guys. Come on, don't fail me now. I know I downloaded something for you guys. July 19, is this it? Oh, you know what happened? That's a problem, it was, I couldn't save it. All right, let me just bring up another one. Let me just go back to Google. And I found something very nice for you guys that I want to share. I mean, I know I downloaded it previously, but it's not sure. It's not showing. And I'm gonna see if I did an extensive search, found one. There again, but I want to see if I can find. All right, so let me just share two things. This is one of them that I'm now seeing here. I know you'd have read this in the in the I know you'd have read this in the document. Let me share this one, and then oh, okay, all right. Now I'm seeing galleries. Okay, it's in the gallery. The one that I wanted to share, I'm now seeing it in the gallery. So let me just go ahead. All right. Now, can you all see my screen?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
So you've read the document. I'm just going to, by the way, was it easy to read? Do you understand what you read?
Yes, sir.
Okay, great.
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. So what you have done for me then, because I have 30 minutes, what you have done for me is to lighten my load. I'm just going to see if I can just make some connections, because when I look at the stuff more and more now, we are getting into the mineralogy of the earth. The mineralogy, what it is that it consists of, and like in the other sections of what it is that we're looking at, I will speak of the composition, some chemical composition of the earth. And what you have there is something that I want to go back to, that I discussed some weeks ago when we were looking at the spherical triangle, and I said to you that it had 3 right angles in there. When I was preparing for the lesson today, I came across this video. I mean, this drawing on the structure of the earth. And if you look at the piece that is cut out, you can almost see where the line up top, if I hover over it, you're going to see it's going to be clouded. But this line here, if you continue all the way down and carry this all the way across and go all the way across with this one, you will see that there is a right angle that is formed in the inner core, and the inner core is right here, so highlighted in green, right? So let us look at it. Where should I start? Let me start with the crust. So the crust, of course, is a solid layer of rock on the surface of the planet, and the thickness varies between 3 and 30 miles. All right. So the crust, think of it. It's pretty easy. So I mean, it can give you something like this in the exam to identify, or to sketch. You should be able to do it. The crust, you know what the crust is, and then after the crust, you're going to have the mantle, right? Now you will see that in another drawing that I'm going to give to you, you will see that I have an upper mantle and a lower mantle, an upper mantle and a lower mantle, similar to how I have an inner core and an outer core. There is an upper mantle and a lower mantle, right? The mantle is the semi-liquid layer of magma or molten rock that moves due to convection currents. All right, so is that layer of magma or molten rock that moves due to the convection current. So what is that particularly responsible for? Can anybody tell me?
Plate movements.
Say it again.
Plate movements.
Plate movements. Okay. So that mantle there is, whenever we have volcanoes and we have these tsunamis and we have these earthquakes and we have all these other things, plate tectonics is going to be a contributory cause to all of what is taking place here. All right. So that's what the mantle is. I just want to identify it because I'm going to get into a little bit more detail with this. And then we have the inner core and we have an outer core. So the outer core is a liquid part of the earth, which has a similar composition to the inner core, right? The liquid part of the earth. And then the inner core says is a solid part at the center of the earth. It is made up of iron and nickel and has temperature reaching 5,500 degrees Celsius. Now, let me tell you, is this a 5,500 degrees Celsius? This is like the three Hebrew boys, Shadrach, Meshach, and Abednego. Some people say Shadrach, Meshach, and Abednego. The story, and you may say by Sir being in the Bible. You remember, geology has a lot to do with the whole creationist theory. So the Bible is a critical part of what it is that we do in this course. Don't ask me, don't say to me that maybe this is why I studied it. It's after I started doing it, I recognize that, maybe Father God was speaking prophetically to me at that point in time. But it's just like those guards. When the king said to them, "Oh, so you don't revere me as being God? Guards, get them three little boy there and fling them into the furnace." And the scripture says, when the guards got close to the furnace, they were scorched. They died. Them burn up. Them not reach out. Them not get a chance to go even close into the furnace, But them guards dead. And the three Hebrew boys went in. No, that is miraculous. Point I'm making here is 5,500 degrees Celsius is no pure heat to play with. No pure heat to play with. Serious heat. All right? So in the inner core, and think about it, the inner core is trapping all that heat from the mantle. Right? So it's going to have a lot of heat that is generated. Now think of that inner core that has that lot of heat. And it is sending in the liquid part. The liquid part is sending is boiling up because of the inner core with the heat that is being generated. And you think of you having a water bath, and that outer core is is sending more increased temperature to the mantle. You must have earthquake. You must have volcano. You must have the plates moving and causing tsunamis and causing these other catastrophes. Yes or no?
Yes, sir.
Yeah, man.
Most definitely.
Absolutely. So for me, it makes a lot of sense. It just makes a whole lot of sense. Get away from here. It just makes a lot of sense because of just by looking at the structure. Just by looking at the structure, it is important for you, on the other hand, to know and to be able to explain what is happening in different parts of it. Now, the article that I sent you also spoke to the specificity of this, the crust, the mantle, and the core. Three main parts, components of the structure of the earth. The crust, the mantle, the core. The crust, you have the upper mantle, the lower mantle, you have the outer core and the inner core, right? So this is one drawing that I want to share with you. Are there any questions based on what I just projected? Let me see if I can find the other one.
So, sir, you said that the mantle is liquid.
Mm-hmm.
But when you divide the mantle into the two that you suggested, there is a molten section and there is a solid section.
Mm-hmm.
How you explain that one now?
All right, good. Soon come to you. Which diagram are you seeing? The one that I just went through a while ago?
No, the one with the section of the but it has the discontinuity seismic model.
Okay. Because I'm not seeing what it is that I'm sharing, right? I don't know why.
The static model, dynamic model.
Yeah. All right. Let me try sharing again. Oh, come on. You are sharing, yes, but I'm not. I'm not seeing. All right. Stop share. A quick answer to your question, Mikey, is remember the mantle. Remember the mantle is a semi-liquid, you know. It's a semi-liquid layer of magma or molten rock, right? What is a molten rock? What do you mean?
Well, liquefied rock.
Very good. So it's a semi-liquid, so it's not fully liquid, you know. But because you have this sort of it's a semi-liquid layer or molten rock. So it is a rock that has been liquefied. So there's no water. It is molten rock, right? And it moves as a result of the convection of the current, current convection. I know you are seeing it, but there's something I want to end the class with that drawing. This is the aim for this one is to show you the base. Go ahead.
It's not up. The drawing is not up right now.
It's not up, yeah, because I'm not seeing it. That's the one I was trying to find. All right, let me go again. I know why I'm not seeing it, you know, because all right. Oh, come on. All right. You know what? In the interest of time, let me just do that. And then let me do that and then just go from I'm logging into another device. I really don't have time to figure out what is happening with this one here. Good. So I want you to look. Let me just put this away. I'll figure out what is happening some later. So I want you to look at this one here. So as I said before, you have the upper mantle, you have the lower mantle, you have the outer core, you have the inner core. All right. Now, where do you want me to start? Let me start from the bottom all the way up. I have a complete document of this that I was preparing for you for the last couple of days. I don't know why it is that I'm not seeing it in on the computer here now, but you know, these things happen. I will find it and I will send it off to you. All right, so I'm going to start from the inner core. Remember I said to you that the inner core is the solid part. That the inner core is the solid part at the center of the earth. So the inner core is going to be the solid part at the center of the earth. It is made up of iron and nickel. Iron and nickel. Listen to me. Them something here reach temperatures of over 5,000 degrees Celsius. That's what the first drawing would have demonstrated. Now, if you look at it now, this other diagram is supporting the fact that it does contain iron and nickel. All right? This one here says to you that it is a solid, and I need to talk to you about this. You see T to the right. Everybody see where I'm going to the right? I can't point to it because
yes
sir. T 4000.
What do you think T is?
Temperature.
All right. What do you think that funny little sign that look like an equal sign?
Like between from
Approximately.
yeah.
Right. So it is a solid, as you would have seen in the first part, and the temperature is approximately 4,400 to 6,700 degrees Celsius. So you see the first one that I show you that it says it gets to a temperature of 5,500 degrees Celsius. Don't ever read documents like these, scientific documents like these, and complain and say, sir, it's confusing because once a 5,500, now this is going to say 4,400 to 6,700. Does 5,500 fall within this range?
Yes, sir.
All right, good. Remember, guys, what I want you to remember. These are only approximations. There is only an approximation to what is happening here. Nobody knows.
But sir, wouldn't it be more accurate if it said, like in this instance, approximately 4,400 to 6,700 rather than just giving an actual temperature?
No, it is saying approximately. That's what it says. That is not an equal sign, you know. You notice that the bottom sign is straight and the top one is curved.
Yes, sir.
Yeah. So that sign in mathematics means approximately equal to. You follow what I'm saying? So that's not it did not say temperature is equal to. That sign is an approximation. So anywhere between 4,400 to 6,700 is correct. So what I'm saying to you, if each of you writes an essay and quote the temperature of the inner core to be any value that falls within this range, you're good to go. That's the point I'm making. So this one is not saying that it is definitely 4,400 or 6,700. It is saying it is a range between the two. So if you decide to go and quote it and say 5,500 or 5,000 or approximately 5,000, you fall within the acceptable range because nobody knows, right? So you fall within that approximate range, right? So you know that that the inner core is in fact a solid. Is in fact a solid. All right. Now, you see that part of the something is called also an endosphere. An endosphere. All right. Now, if you look here, it talks about the depth. To the right, to the left of the figure, it gives you the depth. So it says the inner core is between 5,555 to 6,371 kilometers. Well deep. Well deep.
Sir, which part is that, sir?
To the left of the drawing, the one in purple. Where you see nickel? So at the tip of it is 6371. You not seen it?
Oh yeah.
Yeah, man. So I'm just showing you what it looks like. I mean, this is the best model that I found by looking for this to show you guys as we deal with the structure of the Earth. I may find something else that I prefer, but this is the best one to date. All right. Now, the outer core also contains nickel and iron, but it also contains some levels of sulfur. It says S and oxygen. And guess what? That is where you're going to have the change of state between a liquid and a solid. So that state of the core is a liquid, and which is why the core is broken up into two. The outer core is a liquid part, but it also has a similar composition to the inner core. Based on what I showed you in the first diagram, I did say to you that it has a similar composition. Now you can see that the composition is indeed similar because it contains the nickel and it contains the iron. But it also has some other components that will cause the liquefaction of this nickel and iron. All right. So you have that liquid part of the structure of the earth itself. Now above that, remember it's broken up into three: the crust, the mantle, and the core. So we look at the inner and the outer core. We know that the inner core is solid. Main constituents is nickel and iron. Temperature range 4,400, 5,500, 6,700, whichever one you want to quote, right? Then we know we have the outer core. Same composition as the inner core, contains other constituents. That part is the liquid part of the core, right? So the core is, how do I put this? You ever eat ice cream yet where you have the ice cream is melting and you still have some solid part of the ice cream, but you have some of the ice cream melted and you have the liquid part around it, but it's not fully melted where it is that it's going to be liquidy, so to speak. But it's a transition between the solid phase and the liquid phase. Anybody can figure out and picture what I'm talking about?
Yes, sir.
Yeah, man. Yeah. But what about the others doing class? Can you picture what I'm talking about? I hear in pause.
Yes, sir.
Yeah, man. Asia? Is Asia here tonight?
Yes, sir, I'm here.
Yeah, but you can figure out if you follow what I'm saying?
Yes, sir, I'm following.
Yeah. So it's like that ice cream. It's like that ice cream part that is melted, right? So and if you keep and think of it, don't think of it, say, boy, sir, how long we have the ice cream going to be fully melted, sir? No, because remember, no, it still serves as the same constituent of the nickel and iron, but one is fully solid on the bottom, and then up the upper part now you still have some solid state, but it is almost liquefied but not fully liquefied. So you can see the same composition running right through, but the piece at the bottom is solid and up top is where we have the liquid component of it. And then,
Sir,
yes, go ahead, sir.
I don't even know how this sound outrageous, but I just ask a question.
Mm-hmm.
Right, so, is it a possibility that because the nickel and iron is compressed in the inner core, it becomes solid because the more it's then the once it becomes dense, it becomes solid?
And that too could be a possibility. That too could be a possibility because, yeah, let me tell you what comes to mind. Let me ask you why, though, you ask a question that way, and then I tell you what comes to mind.
Sir, because, all right, the mere fact that the inner and the outer has
similar stuff,
similar consistency are elements. For one to remain in a liquefied state, it has more space, and as it becomes as the space becomes narrow, and the material becomes denser, it becomes solid. So I was wondering if that has anything to do with it.
All right, let me I like creating analogies, so it is that we can make some levels of connection. Anybody knows what dry ice is? What is the constituent of dry ice? What is dry ice?
Carbon dioxide.
In what state?
Solids.
All right. But you know carbon dioxide to be what? Original state?
I guess.
So when the carbon dioxide is compressed, it now becomes that solid state, and it is used as a refrigerant, don't it?
Yes, sir. Very, very, very cool refrigerant.
And guess what stupid me used to do? And I'm sure I'm not the only one, because if only make me
Smoke
feel
it.
stupid, so I know I'm not the only stupid one, all right? But let me tell you something. It's my fudge man who always pass the yard every day, and you always buy a little icicle or a little ice cream cake from him. Him knows so when him come and stop at this yard, him have to take out a few dry ice and give to me. And because me see people around here smoking, me used to smoke my dry ice. But something used to happen to me every time I smoked this dry ice, and I did not understand until I started doing chemistry. I said, oh, but look, I could have killed myself and don't even know. Ignorance is bliss. Trust me, you have no clue. Not a clue in the world. You understand? It's dry ice, it's froze, it's carbon dioxide that is in a solid state. So the carbon dioxide in the gaseous state is the same carbon dioxide in the solid state. The only thing that is different really is the change of state. And guess what, Mikey and the rest of you? Before that gaseous state, carbon dioxide, gets to the solid state, there's an intermediate state that it has to go through before it gets to the solid state. Talk truth.
Yes, sir. So
Yeah.
it has to become, it has to go into like a liquefied state.
Right. No, right. So what can happen, others will say that you can have a sublimation. Sublimation, it means it moves from one state to the next state, to those passing through another state, right? But in this your case, put it this way, you're at the core. Put it this way. Let me jump to the lithosphere. Let me jump to the lithosphere. And you may say, sir, where's the lithosphere? All right, look here. The lithosphere is where me walk on. It's where me walk on is what is called the lithosphere. You see the big mango tree them where I grow and they carry them and drive on the road and them something there? That is the lithosphere, right? What we are seeing is the lithosphere. It is solid. So the question that you're asking, Mikey, is think about the amount of weight on the lithosphere that is compressing on the inner core of the structure of the earth. You think that is pure weight?
Oh, sir, that can be.
Listen to me. I mean, look on them big. Trust me, me I come from a place a while ago where you had them big structure. And when you look on them big structure, sit down on a piece of the lithosphere, trust me, the earth has to be strong in order to hold that up. Has to be very strong in order to hold that up. So you're going to have a lot of compression. So the mere fact that a piece of it can be in the liquid state, it speaks much about it. And why it's in the liquid state, I believe, in my view, I need to read more about it. Why I believe it's in the liquid state is because of the temperature that is there. It is, which is why I use the thing with the ice cream. It is not fully liquid as it is. It is liquefy, running up and down, It is liquid, but it is liquid nickel and iron. So if you don't mind sharp, it is liquid solid, but it has some liquid part to it. So why they separate? The first one, why they separate the outer core from the inner core is that they can say to you definitively that the inner core, the innermost part of it, is definitely solid, but the top part of it is it's not fully solid. So we're going to call it liquid, but it's not something that is going to run up and down. And why I say that? Because when you look at the endosphere is where the inner core is. The core is the inner and the outer core. That's where the endosphere is. But the core, the inner and outer core, the inner core is solid. The outer core we're saying is liquid. But when you look at the mesosphere, what state is the mesosphere?
Solid.
It is solid. Yeah. So think about it. If the mesosphere is solid, and we're saying that the endosphere, the upper part of the endosphere, which is the outer core, is liquid, what do you think would have happened if Put it this way. If you put one piece of board, all right, we could use it. It's a solid plastic. If we put one plastic in a water and we push it down, and by I'm saying push it down, because remember we talk about the lithosphere, a lot of heavy stuff on the lithosphere. If we push down the water, rubbish. If we push on the plastic on the water, what is going to happen?
The plastic will float.
Yeah, the plastic will float, yeah? But what will happen? Does it displace any water?
In this, yeah, displace water.
And Archimedes' principle can't lie. So the amount of, so this is how a ship sails, you know. When the ship moves on the barge, and it is always fascinating how they move those ships, right? Lick off the two something and the ship just run down into the water. Guess what? The ship displaces as much water as the weight of the ship. The water that is displaced is exactly the amount as the weight of the ship. You follow what I'm saying? And that's why the ship is able to float. The ship is able, huh?
I don't understand. Why would it say solid plastic though? For the
You tell me why I think it's a solid plastic.
I'm not sure, sir.
All right. Oopsie daisy. That's a very point I'm trying to make, Paz. That is when we speak of liquid, I don't want to think of liquid water. Water liquid. That's the point I'm making. So it is liquid, but it is liquid with some. All right.
They're not hearing.
Sir?
Recording in progress.
Hello?
I'm hearing you now, sir.
All right, good. I apologize. Asia, you know, say, it's you me that got trouble, you know, and then after me calling him for start trouble you, there's something just went. So maybe the Lord is saying, why troubling good Asia? She come class and it's a sign, me think so.
Sir, don't trouble Asia.
No, but me got trouble her still. And any how it happen again, me know some enough for trouble her. Let me see if Benika is in class tonight. Because if Benika is in class, I will not trouble Asia and trouble. Benika is not in class, I'm going to trouble Asia. So no, Asia, this is a situation. So I was saying to you, speaking to myself even, based on the question that Paz asked, is that, you know, sometimes you're cooking and you have real gravy, and you have the gravy well long, and I say Asia wouldn't understand because Asia can't cook. So, anybody knows what they're talking about when you have good gravy with body versus gravy? Just stop answering, Asia, mute, Asia, mute. This conversation is not yours because you know you can't cook, Asia. Come on, man. Make Davia answer and Alexia answer and the rest of them. Even Mikey can cook, Asia, sure. But Paz, I'm not trouble here, Asia. I can pick at you because you always help me out in class. So Paz, you were asking the question, and I was trying to find something to say to you. So you see, when you're looking at your gravy, for argument's sake, you will have gravy that still tastes nice, you know. It still tastes nice. It's the same constituent, but the gravy has too much. It is not molten, it's liquid. So the difference between molten and liquid is that I can have molten sodium chloride and I can have liquid sodium chloride. Liquid means that or aqueous, that water is added to it. Molten means that it is in its natural state, but it's just liquefied, right? So the question that you're asking, Paz, is how can I have solid plastic existing? That is it. So you have solid existing atop some liquid, but the liquid that it is existing on is if you look into the yellow part, son, look into the yellow part where it says the transition zone, moving from a liquid to a solid. Don't think, which is why I use the ice cream situation, don't think that you will have pure liquid atop the inner core. No, it's a transition state. So a portion of it is liquidy, yeah, but another portion is solid.
Okay.
No, but guess what? No, something else comes to mind. Remember, we speak about these whenever we have earthquakes or whenever we have volcanoes, you see the magma that comes out.
Yes, sir.
It is section of this liquidy part, you know. It's section of this liquidy part that comes out. When we speak of viscosity, we're talking about, come back to the gravy, how thick the gravy is. The gravy thick or the gravy lenke, right? So when you have those volcanoes where your magma is viscous, it means that it's very thick and it moves slowly, versus when it loses viscosity, it means say it not so thick. So the magma is going to be running and run very fast. In a case like that, may you not have no time for escape, because by the time the volcano reach, we have to run left it, or else we are going to be absolutely right. So you have a different gradation of stuff. So you're going to have some plasticky part there, and that is the mesosphere, right? And then now you're going to have a section that is called, see there, I didn't even recognize that they use the word here. In the asthenosphere, you talk about viscosity, and that the arrow going up mean that an increase. The arrow mean that is an increase in viscosity, right? So it's a part of the upper mantle. It's a part of the mantle, but again, you're going to have that sort of transition zone, because remember the upper mantle there versus the lower mantle, you're talking about it being solid plastic, and that's a mesosphere, and then in the asthenosphere, you're talking about it being viscous. So it means it is almost solid. Talk truth.
Sir.
Yes, sir.
Could solid plastic also refer to when plastic is melted, or you start to melt plastic? It's
absolutely.
It's flexible.
Absolutely.
But not necessarily liquid.
Absolutely. That's the point I'm making. So this is how I was talking about the gravy. So you have the nice oxidized gravy, where thick and nice, versus a gravy where you just start making. When you just start making the oxidized gravy, it's not ready yet because it's not no body. You know, when people say the gravy not a body yet, so you just make it stay there and want to evaporate out some of the water until it becomes very thick. So you're going to have that sort of plastic solid in the mesosphere. But the asthenosphere now is where the viscosity is going to be a little bit higher. So you have your plastic, right? When you melt it, or let me go back to the volcano. You have your magma that is running very fast. They say, blow, whoa, it don't have much viscosity because it run too fast and you can't outrun it. You can't outrun it because, I mean, you can't climb a tree and say you're going to escape it because the amount of heat that is generated is going to burn the tree, and at some point in time, the tree is going to drop. And the mere fact that the tree drop, the tree is going to be, matter of fact, the tree is going to catch a fire, right? The houses are going to go, the light poles are going to fall, the electric wires are going to be exposed, and then we're going to have a catastrophic event taking place. Which is similar to what happened to our sister island recently. So you have to move to an area, and if you're going to the water is going to heat up. So damn if you do, damn if you don't know where else to go, right? I'm cognizant that it's 4 minutes past, and I don't want to be like your teacher that keeps you up. But this conversation, I have to go through more with you because we need to understand the whole of the earth. Because I don't reach a lithosphere to know. I don't reach a lithosphere because when you get to the upper level, you will hear me come back and talk to you about the lithosphere, because the lithosphere is one of those areas that when you drive through the north-south highway and you see them cut through the hill just to build some roads, that is the lithosphere that they're cutting through, the section of the earth. And the lithosphere is that section that is not being taken care of. One time you drive on the highway and see, we call it land slippage, because the lithosphere now take the lithosphere.
Sorry, you're breaking up.
Environmentalists.
Sir, we're not hearing you now. You're breaking up.
All right, sorry about that. Let me see if I can. Are you hearing me?
Yeah, we're hearing you now.
All right. So I'm just saying this conversation has to continue because we have to go through the other composition of the structure of the earth so you can have a fulsome understanding of what is expected of you. I know it's 6 minutes past, and I know you have another class. I don't want to be like your lovely teacher. So on Monday, I'm going to ask you to read up for me. Between now and Monday, I'm going to be sending you the document so you can have a look at it, and then we can talk more about it. Because the truth of the matter is, you can be asked to do something like this in the exam, and you should know what the structure of the earth looks like. All right? Bless up. Thanks for coming out.
All right, sir. Nice.
Yeah, man.
Nice, sir.